All right. So there was a couple questions on the review, so we can get that real quick. Okay. So this was talking about Lindsay. This is problem number 2 from your review. Lindsay also runs the 400 and knows that her score is normally distributed a mean of 57.6, standard deviation 2.7. Find the following probabilities. So this is problem number 2. We know that problem number 2 about Lindsay. So she has this for an average time, and she has a standard deviation of this. Okay. So yesterday, as Jordan came in, I was helping her a little bit, and we had a pretty good analogy, I think. Jordan runs. I don't know if you guys knew that or not. But I asked, I said, do you always run your best time when you run? She goes, oh, no. So, you won't always have your best time, so that's why, this type of situation we're talking about Lindsay, this particular person in this problem, has this particular 57.6 seconds, but doesn't always get it. There's a certain range that this person gets it to. So let's just think about what the normal curve looks like for this person. So in the middle, half the information, half the information is to the right, half the information is to the left. This is at the 50th percentile if you wanted to say something. But over here you would add 2.7. Over here you would add 2.7 again. And then one more standard deviation, add another 2.7. Over here you would subtract 2.7. And this is all coming from subtract 2.7 again. And then if you want out one last standard deviation. So that's basically what's taking place. So it says that it takes her longer than 60 seconds. So what is the probability it takes her longer than 60 seconds? So what you have to do is you have to realize that 60 seconds, 60 seconds is probably right here. So we're talking about what's the probability that it takes her longer than 60 seconds. So if you're talking about longer, you're talking about this area over here. Okay? Now your calculator can do this work very easily for you without if you use the normal table in the back of the book, what's something you'd have to do in order to get your answer here? 1 minus whatever that area under the curve would be. But if you used your calculator, so the calculator, you have second vars, okay? And this is a normal distribution. And so what you're going to do is, remember this is your lower limit, this is your upper limit, here's your average, and here's your standard deviation. Okay? So what is the lower limit in this problem? What would the lower limit be? Would it be 0? Yeah, it'd be the 60 because I'm trying to find the area to the right. So I'm going to go 60. What should the upper limit be that way, and how should we know? Like 100. Okay? Now, again, some people might say, is 100 far enough out? Shh. If 57's here and I'm growing by a rate of about 3 each time, 100 is way out here as far as our item would go. So we are plenty far to the right to find the area under the curve to the right. Okay, and then I have my average of 57.6 and my standard deviation. And then the calculator is going to work real nicely to plug this all in under normal distribution. Okay, so second vars, normal CDF, and then 60, comma, 100, comma, 57.6, comma, and 2.7, close the parentheses. Now some of your calculators, you actually have to plug it in, in going down, and then you hit enter, which will make it look this way. But this right here is 0.187. So 18.7% of the time, Lindsay will take longer than the 60 seconds on this particular race. So that's letter A. And then letter B says that she takes fewer than 56 seconds. So if she's going to take less than 56 seconds, 56 seconds is like right here. So you're talking about the area under the curve over here. Okay? Area under the curve here. So what is my lower limit going to be up here then? It could be 0. 0 would be fine. I mean, this is my standard, or my average. My standard deviation is going to go about 3 to the left. So if I took 0, 0 is way off to the left over here. You could also probably pick 40, and 40 is still going to give the same answer. But 0 is a good start to say, okay, I want the area to the left. We want to know that she's going to go 56 seconds, less than 56 seconds, and this are both the same. They're not going to change. So these just come straight down. Okay? And again, if I plug those into my calculator, I'm doing a normal distribution. Okay, so I have second, bars, normal, 0, comma, 56, comma, 57.6, comma, 2.7, close the bracket. So this means that 0.2767 or 27.67% of the time, this person is going to run faster than 56 seconds. Even though the average is 57, there's still going to be the opportunity for this person to run faster a certain percent of the time. And then letter D, letter C takes between 57, so like from here, to 60, so like here. So you're talking about this area here. Okay? So am I still doing a normal distribution? What's my lower limit? Yeah, your lower limit's the 57. Your upper limit's what? 60. Is the average and the standard deviation still the same? Yeah, you're talking about the same race. So those are both going to be plugged in. So again, normal distribution. Now I'm just going to find this area in between these two. So second, bars, normal distribution. I got 57, comma 60, comma 57.6, comma 2.7. Close brackets. Enter. So this means that this person's going to run between 57 and 60 about 40% of the time, 40.09% of the time. Does that make sense? And then letter D, so all of those were all done the exact same. Normal distribution, you're finding the area. Either find the area to the right, which you're going to use a top end limit, area to the left, which you could probably use 0 for your limit, or in between, and it gives you the two in between values. Then letter D says, if her time is in her best 5%. So if her time is in the best 5%. So her best 5% is like over here. Okay? And with this is we want to know what time is this going to allow us to get 5% of the area to the right. Ideas? How much area is to the left? Yeah, 95%. So from here over to this way, all that area is going to account for 95% or 0.95. Okay? So I could do this one of two ways. I could use the table in the back of the book, and you'll be given a table for the test, or you could use a calculator. If you use the table in the back, you're looking for 0.95 of an area. So it looks like 1.65. So if I look at the back of the book, my z-score is 1.65. This is pretty close to 0.95 of an area. And if I did this, then I'd go 1.65 is equal to the average, or equal to the observed minus the average over the standard deviation. Do I know the average and the standard deviation? Do I know the mean and standard deviation? The answer is yes. So what you would do on this is you would plug 57.6 in here, 2.7 here, and then use algebra to solve it. Or you could use your graphing calculator. Okay? So you're looking to undo an area. So you're going to use inverse norm. Okay? And the inverse norm will require three numbers. It's going to require the 0.95, because that's the area that's to the right. It's going to require the mean, and it's going to require the standard deviation. So again, if I pull up my calculator, it's under second vars, and it's the third one. So again, I'm going to plug 0.95 in, comma, my average, which is 57.6, comma, 2.7. Close the brackets. Here we go. So the score this person would need to get here is 62.04 seconds. That's where this person would start running in their top 5% of their times. Okay? Should this number here be to the right of the average? Why? Yeah, you're talking about the best 5%. So you're talking about this region right here, that area. The reason I'm using 0.95 is because all of our stuff will read the area to the right of that. So if she's running to score in 95% of all data, if I do the inverse norm of it, I will get this 5%, which on the calculator says that, hey, if she runs 62, a smidge over 62 seconds or better, she's going to be in the top 5% times. Okay? Did I go backwards on this? Yeah. So that's her worst 5% times? Is that what I'm saying? So I need to go over here, right?
But then what's best? It says best though.
Yeah, but lower times best time, right?
So would it be 5%?
0.05.
Yeah, that's what I had.
Yes.
Like, so
I'm sorry. All right, so all I'm doing, so that 0.95 was 95% of her times
like
were
18%.
there. If I put the 0.05 in, I'm going to get over here. So I can go back in and do that real quick. Oh, I'm sorry. Why did I goof that up?
Sir, how long is the test?
30-some questions. So let's do the inverse norm, plug in the 0.05.
Is it multiple choice?
Yes. So the answers are there. Things I will tell you on the test is this. I'm sorry, I didn't mean to goof this up. So this is the best top 5%. So if this person runs 53.15 seconds or less, this person is a rock star there. Sorry, I went backwards on that. But
Will
so,
the other one be 85 then? Because the other one's 15% or worse.
or worse?
Yes.
Yeah, I did them backwards.
So that'd be 85.
85. So the other one, if her time is in her worst 15% of the times, so the 15% is going to be over here. So that would give you a 0.85 that you plug in. So I just did the two of them backwards, but same idea.
But with money, it would be the other way, right?
Yes.
Yeah.
Money, yeah, absolutely. You're right. Unless it was like a sale price.
Oh.
Okay? So inverse norm, and you get to this by going second vars. Inverse norm is area, standard deviation, or mean standard deviation. And this is to find a score. If I did the normal CDF, this is lower limit, upper limit, mean and standard deviation. This is to find an area. And in order to find the probability is make area a percent. Okay? That's it. If you can do that, and then I will tell you this, that in order to find a z-score is like what?
Wait, how do you do number 4?
It's not even on the test.
It isn't?
Less than or more?
No, it's
Z-score. What is the Z-score?
Observed minus average over standard deviation.
Observed minus the average over the standard deviation. The Z-score is just like what? It's a standard deviation with decimals is all it is. Hey, what? What? Let me see it. Uh-oh.
specifically
I don't know if I have an extra one with me or not.
Calculator? Can I go get one at the resource center?
Yeah. Hey, Lenny, take your